Good morning, everyone. My name is Ragunath. I work for this agency called Obvious. Obvious is a design agency based out of India. So we specialize in web application development and Android development. We've worked with most of the unicorn startups in India. And at Obvious, I specialize in front-end architectures, testament development, refactoring, and workflow optimization, right? And several years ago, when I started out as an independent developer for building Android applications, Android had just started, right? And then we were building very simple applications like this. This is a very simple application, which is a soundboard application, which helps students learn mathematical concepts. So you have a bunch of buttons, you tap on the icon, and then it starts playing things, right? These are very simple applications, and you can build them within a few hours. All you have to do is put everything inside the activity, override a bunch of lifecycle calls, and then you'll be done. And mostly they were bug-free, right? And then the application market started maturing, and people wanted to do more and more. That's when the requirements started coming in, right? And these are applications that would take you a while to build. They were not very simple applications, but you can build them probably in a few days, and then you can ship to the market. But then they started having bugs because you had a lot of use cases that you had to satisfy. And then a few years later, the applications became more and more complicated. They had relatively nicer looking UIs. And they had multiple features. In these features, we had teams of developers working together, probably one or two developers working on them. And then they had databases, they made network calls, they had all sort of complicated stuff. And then things started going downhill, right? Because it was very easy for us to build applications that were relatively simple and bug-free, but the moment you start adding too many features, and then the moment you start bringing in too many developers, you still cannot retain the same kind of quality and productivity that you used to have. And this started troubling me, and that's when I learned there is something called as an architecture, right? So architecture is just a way for developers to set expectations among their teams. So say, for example, hey, this is where I'm supposed to make network calls. Here is where I'm supposed to make database calls. Here is where my business logic should be, right? So you set expectations for other developers so that you can still be productive, making changes when required. There are a bunch of architectures. There are quite a lot of architectures to choose from, and you can pick and choose whatever you think is really good for your own use cases. And I'm pretty sure this is not an exhaustive list, and some of you may be using something that's totally different and it's not listed here at the first place. The way I would like to think about most front-end architectures, considering the view, is like this, right? You have a view, and then there are a bunch of boxes. In this case, there are 2. You could have 5, you could have 7, you could have 10, depends on what you're trying to accomplish, and then the complexity of your domain model itself. And what we are trying to do here is trying to synchronize state from one or multiple of these boxes to your view. That's what we are trying to accomplish, right? And the Android view system works. The toolkit currently works, but it was built with a mental model that was familiar with developers maybe a decade ago, right? And here are a couple of examples that I would like to show you and tell you where this fails, right? So let's talk about state. So most of you might have built something like this. It's a simple list view. Here it shows a list of patients. And what we're trying to do here is trying to expand a view and then scroll down, scroll up, and see what happens, right? And let's start from the top. We're trying to expand the first item, and then we gently scroll down. We keep scrolling down the list, and then you see something unrelated is expanded. It's not in relation to, it's not what you expected, right? And then I'm going to try to collapse this, and I'm going to scroll back again to the top, and you see the first item is collapsed, right? So this is a bug, and I've seen most of the people have run into these kinds of issues whenever they work with Recycler View. One of the reasons this happens is because we're trying to do explicit state management in the view itself, right? And this is one such simple example. where you know the problem is at your UI layer itself. There are also other cases. Say, for example, when you look at this screen, it's already expanded. And when you try to click on one of these, like probably you want to remind to call this patient sometime later, then what happens here? There are a couple of things that could happen. I think the most sane way to do this is when someone clicks on the button, you dispatch a callback, and then to your repository, make the changes, update your repository, and then the repository notifies you back through a presenter maybe, and then tells, hey, this has changed. Why don't you go update yourself, right? And what we're doing here is actually trying to take states from two different places, and then we are updating it, right? Maybe that's the same way to do it, and the other way to do it is to assume that your database calls will never fail, update the view, and fire and forget a database call, right? There's nothing stopping you from doing this as well. And any kind of bug that happens in this scenario, it's really hard to find, because you need to set breakpoints in multiple places if you don't really have any tests, and then figure out what went wrong in which layer of the application itself. So you notice that when we use the current UI toolkit, we're doing too much state management explicitly in the view. There are too many tech stacks to deal with, right? You're writing XML for your layouts, you're probably doing a custom view, then you're writing XML for your custom attributes, then there is styling, then there is theming, and then there is your Java or Kotlin code that comes into writing your view itself. And then we use inheritance as the primary means to use code in the current UI toolkit, right? So if you have a component and you want to enhance it, you just like subclass it. But what if you have two different components and you want to have an enhanced version of the two? Then basically, the inheritance model stops working. Before we go ahead and look into Compose, I want to take a detour and talk about mental models, right? When I say mental models are the way how we approach problems in general, right? So we say, hey, here is a problem, and this is how I think this problem should be solved, and then you act based on your mental model, right? And I think there is something that almost everyone in this room could relate to in terms of mental models, is how we do asynchronous programming in Android, right? And this has changed quite a lot in the recent years. I'm going to show a bunch of code, and that's just to illustrate the idea and the mental model. It's nowhere correct. So bear with me for a second. Let's say we want to do two different asynchronous calls. We want to get a user using a registered email, and we're going to get a list of bookings for this passenger, right? So let's see how we can do this in multiple ways in Android. One of the most common ways that you're familiar with is to do callbacks, right? So we have a function that is going to make a long network call, and then it also takes a callback. So you say, hey, I'm going to do this, and when you're done with it, just let me know through the callback itself, right? And since we're going to get the passenger, and then followed by the passenger, we're going to get the list of bookings, we're doing nested calls, right? And you can pretty much say that this is not going to scale, because the moment you start introducing more and more asynchronous calls, then you're probably going to grow a Christmas tree in your IDE, right? And callbacks did not scale well, but it's also a mental model that helped us with asynchrony, and then we moved to this, right? And the way when you work with something like RxJava, the way we think about it is we imagine a timeline where events happen over a period of time, and then we perform a bunch of transformations on the events that are happening, and then try to solve the problem at hand. And this is one way to solve it, right? And then there is this mental model of coroutines, right? And when I show this piece of snippet, I would like to highlight a couple of lines. So if you look at this code, when we are using coroutines, your imperative asynchronous code is going to look like your imperative synchronous code, right? So this is a mental model that we are already familiar with, and we know that this is not going to happen immediately. It's going to suspend before you get the result. But this model really works because the way we approach asynchronous programming now has actually changed. So in terms of coroutines, we've been lucky enough to bring in a mental model that is already familiar to us, right? And in most cases, given the problems at hand, this works really well. But in some cases, we have to invent or look at a different paradigm to solve the complexity of the problem at hand. So Compose is, on the surface, may look like just another library or a framework. But Compose, in fact, changes or makes you think in a different way to solve problems that we currently have with the Android view system itself. So I also want to go ahead and talk about the mental model that is behind Compose. So the first thing that you will notice is, in case of UI, UI is always a function of state, right? Let me expand a bit on this. So we have state, which is data, which could be portion of your UI, or it could be the portion of the entire screen. It doesn't really matter. And we have this data, and then we apply a transformation function to it. So UI is just a side effect of the state of the function itself, right? And if you look at this, the UI is at the left-hand side of the equation. Yes. So the UI is at the left-hand side of the equation because only by changing the function or the state, you can make changes to the UI, right? And you cannot reach into the UI and make any changes in the first place, right? Because any changes that you make to the UI is not going to have any effect, right? But there has to be a way to enforce this, because in the current Vue system, you can still kick off business logic by changing things on your UI, right? And this is not something that we really want. And the first step in moving towards that direction is this. When we compose, there is no way for us to get a reference to a view itself, right? And how are we doing this? Remember that we said UI is a function of state, right? In Compose, you have functions, or composable functions, or composable components. These are the basic building blocks of your UI itself, right? So a compose function is just like any other regular function that takes some data, and then when you invoke this function, it's going to emit a node in your UI hierarchy. And this function returns unit, so it doesn't return anything at all at the first place. And then we are going to annotate with composable. Composable is an annotation that performs some transformations on the body of your function, because compose is a combination of a runtime library and a compiler plugin. And the primary use case of Compose is to build and efficiently manage any kind of tree-like data structures. It's not necessarily tied up to your view itself. So what Compose does, it performs transformations on the body of the function so that you can actually efficiently build the tree from the ground up. You could also reconcile changes between the old version of the tree and the new version of the tree. And then in case if you want to reconstruct a sub-tree in the entire view hierarchy, it does that efficiently. So that's what Compose does. And let's take a look into an example. This is a fairly simple example that I'm going to show you to get a feel of how the Compose API will look like when you're trying to build something by yourself. The example itself is slightly interesting. What is more interesting is the observations that we will talk about once we are done with this, once we run through this code example itself. Take a look at the screen. It's pretty simple, and this is something that like most of you would have built already. On the left, we have the name of a product, like a fruit here, an apple, and then the total cost of it. And on the right, we have a stepper, right? And stepper lets you increase or decrease the quantity of items that is present in the cart. Now let's go back and apply this principle. We know the UI is always a side effect from the transformation that happens on your state itself. Let's try to build the state first. If you talk about the state, it's just a simple data class, and it's called a fruit. Then we have a property that says name, which is immutable. And then we also have another property called price, which is immutable again. And then we have quantity, which is mutable, right? In addition to these properties, we also have a computed property called total price. What it does, it takes in the quantity and the price of the object and then computes the total price for you. That's all we have. If you notice, this has an annotation called as model. What model does is when you create a view hierarchy with one of these models, and what model does is it will start observing field back properties in your data model, and when one of those changes, it triggers a recomposition, which means if one of this property change and you have a field that is bound to this property, that portion of the subtree is re-rendered or reconstructed, right? So that's how it works. So if you notice, we have a bunch of properties. We have quantity, which can trigger a change. And then we also have total price. Even though this is a val, it is backed by a mutable property. So when quantity changes, and if you have a field or if you have a UI element that is bound to total price, that will also recompose and then show a new thing, re-render the UI for you. Now we're done with state. The next thing that we're going to do here is we're going to look into the function itself, right? So let's go ahead and write a function for this. I'm going to break this up into two different parts. So we have the stepper, and we're going to build the stepper first. So the first thing that we do is like start writing a regular function. It's called stepper, and then it takes in a count, which is the thing that you want to show on the stepper itself. And then you have a callback that tells when something changes. And after that, we saw the stepper was probably a linear layout with horizontal orientation that had a button text view and followed by a button again. In Compose, we have something called as a row. So the row lets you put widgets horizontally in it. So the first thing we're going to add here is a button. So there's a button with a text property minus. And then I want a little bit of space between my button and my text. So I'm going to say, hey, I want a width spacer 8.dp. And if you notice, there is 8.dp, which means you don't really have to worry about how to calculate device-independent pixels for your UIs, right? And then, followed by the width spacer, I want to say, hey, my text view is going to be of a fixed size, which is just 24 dps. So I'm going to wrap it inside a container, and then I'm going to say text, right? Text has a text property that is bound to the count property itself. And then we also have style, right? And then the style, it's type safe because when you use Android Studio, like the auto suggestions will give you only the list of properties that are already predefined. In this case, it's body. And after the text view, I want to have a little bit more space, so I'm going to add 8dp, and then followed by that, I'm adding a button, right? And if you notice, the UI part is almost done, right? There's nothing else. In terms of Android, if we were to build a composite component like this, then probably we need to have a layout.xml that has a linear layout as a root, and then followed by a couple of buttons, and then you'll also have a text view. And then when you write the Kotlin code or the Java code, then we introduce a state, and there is theming, styling, whatnot, right? Like there are like a lot of things that has to go into just to make your widget visible on the screen. But in terms of Compose, this is all you're supposed to do. Now let's go ahead and add some behavior to this. The first thing that we're going to do is like we have to add a behavior to minus. So we say on click, if count is 0, because we cannot go below 0, we say have this listener or else null. So in the current API, for you to enable or disable a button, the only way to do it is to set the on-click listener to null, right? These are not final. This may change in the future, but currently, if you want to enable or disable a button, this is the only way you can do it. And if you look at onRemove, what our onRemove does, it's just a Lambda function that calls onCountChange with count -1, right? And then if you look at the positive button, it's another Lambda function that takes onCountChange and then adds 1 to it, and then we're done. And if you notice, can any of you see any state here? This is a completely stateless widget, right? It's a completely stateless widget, and it's also called as a controlled component because it does not hold any state onto it. This is one of the patterns that we'll increasingly see while we are building applications using Compose. And then finally, we just annotate the function with @of composable. If you look at this, then our stepper is done. The next thing that we're going to do is we're going to build out this row. The way we're going to do it is, again, define a function which says function fruit of row, and then which takes in a fruit itself. And inside the fruit, we have something called as padding. And when we specify a padding, we are actually using composition over inheritance. In the current UI toolkit, what we would probably do is have a padding property that is set up really high in the Vue hierarchy, which would be our Vue class. And then all classes that are subclassing this would inherit from this, will inherit these properties. In terms of Compose, we favor composition over inheritance. So widgets don't really have a padding property. All you have to do is, like, say, for example, if you want one of your widgets to have a padding property, wrap that with the padding widget, padding itself, right? So that way you can mix and match, and you can have several combinations of this. And here, for the padding, I'm going to set edge insets. I'm going to say, hey, on the left, I need 16 dps of padding, and then on the right, I need 16 dps of the padding. And followed by that, I'm going to use a flex row, because if you notice the image, we need the text to take all empty space that is available after drawing the stepper on the screen itself. And then we say expanded 1, and that just means like take all available space after all other children are laid out. And then we say text, and then we bind the name of the fruit, and then we also bind the total price to this. And then we also add the style property. When you add the style property, we say, hey, give me h6, right? And followed by that, we're going to say inflexible. And in terms of inflexible, we're just going to put the stepper inside, because the stepper can occupy as much space that it needs. And then we're binding it to the quantity property. And whenever the count changes, we're just updating the mutable property on the model itself. And at last, we're just going to annotate the function with the composable annotation itself. Right. And even if you notice here, we're not dealing with state here. Like, this object does not own any state by itself. The next thing that we're going to do is figure out where the state is. Let's say we have these two components, but we need to bring in state somehow. And the way that we're going to do it is use something called as a fruit app. So the fruit app is just a top-level function that takes in there's a bunch of boilerplate in there. Like, say, for example, it has the current material style, material typography, and things like that. And it's just things that you want to set up at the root of your class itself. And followed by that, we have this thing called as apple, right? And we create a new fruit, and then we do a memo here, and then we assign it to apple, right? This is quite interesting here, because when we start building applications for Compose, there are three things, right? There is composition, where the functions are called from top to bottom. And when that happens, your UI tree is being constructed for the first time, right? And when something changes inside the tree, like, say, for example, some mutable property in your model changes, that triggers a reconciliation where the functions are called again, and then the differences between the old and new tree is computed, and then the tree is reconstructed again, right? So when the function is being called from top to bottom, and if we don't have a memo call here, then it will recreate the fruit object itself. In that case, we'll lose all previous state. One of the ways to retain the state is by using something called as positional memoization, which Compose uses to cache the current value, and whenever something changes, it compares it with the value and then triggers recompositions based on that. And here, since we don't want Apple to be reinstantiated over and over again, we're going to wrap it inside a memo call, and then that's going to give you a memoized value of Apple itself. So that way, when a recomposition happens, your tree, only the portion of the tree that has changed is redrawn, and the rest of it is left out. And then finally, we go ahead and say fruit row, and then we create the apple itself. Right? So we pass in the apple, and this is how it looks like. There are some observations that I would like to bring to your notice in this case. So the first thing that you noticed is the smallest reusable unit in Compose is a function, right? So when you're trying to reuse views or widgets, you can always reuse a function and then make it appear in multiple places. Say, for example, when you work with most of the design teams, and if they are using a tool like Sketch, then your designers are probably giving you a set of symbols, and these symbols are used in multiple places within the application itself. So for you to build a UI library that is very specific to your application, all you have to do is start recreating these symbols using Compose, right? And since everything is in your function, like say, for example, your theming is inside a function, your colors is inside a function, your typography is inside a function, I'm pretty sure like most of us developers have reasonable skills with organizing code, but not really experienced with organizing XML. And since Compose lets you write everything in Kotlin, you can just go ahead and reuse it and build a library and distribute it among yourselves. The other thing that you noticed is like not all components need to have a state at the first place. You can still build components that do not have state in them, which are easy to maintain. And these are called as controlled components. Say, for example, the stepper was a controlled component because it did not deal with any state on its own. And there is this pattern called control components in React, and that's a pattern that would be used extensively across Compose itself. And we also noticed there was just one single source of truth. The UI itself, we did not have any access to any of the properties in the view itself. So there is just one source of truth, and if something changes, you just have to go look at one place, right? And this also opens up a lot of possibilities. Say, for example, if you have 3 different widgets showing the same information in 3 different forms, what you have to do is, in the current UI toolkit, we will have 3 sources of information, and these 3 sources of information will be part of the widget itself. But in this case, you can have one single source of truth and then have other widgets listening to this source of truth. And you'll also notice that the structure of the code that we wrote, the functions that we wrote, would exactly match the structure of the view hierarchy itself, right? And since we started from the bottom of the tree and then moved to the top, we built the entire application starting from the leaf to the node, which means, as a nice side effect, we pushed all the state as close to the root as possible. So every state that we are looking at was as much as close to the root of the tree itself. There's also a declarative. So when we talk about declarative, XML is also declarative, right? So what's the difference? When we talk about XML being declarative, XML is being declarative in a static sense, right? And most of us also enjoy writing UIs in XMLs, like at least before constraint layout came in, because it's pretty easy for us to write it, right? And the problem with XML is it can only serve static content, right? And then for us to make it more dynamic, what we do is like we inflate a view, and then we try to reach into the components that we're interested in, and then we start setting properties, listen around to this, to introduce a dynamic behavior into the view itself, right? I've been fairly successful doing this because there have been attempts like data binding library, which allows us to make the XML even more dynamic, right? But it only takes us so far. And the other thing that I wanted to talk about when I mentioned declarative is, say, for instance, let's take an example where we have a screen with 3 different things where you're making a network call and loading things and showing them on the screen, right? And when you're doing this, first thing that we're going to do is we're going to show a progress bar on the screen. Second, we get a result from the network. And third, we're going to display the list on the screen itself, right? And when you transition between one of these UI states, we have to remember the current state itself. Like, say, for example, I set the progress bar visibility to true, and then I make a network call, and if I get a result, I'm going to set the state of the list view to be visible, show the list view, and I also have to hide the progress bar, right? So even though we are dealing with the current state, we still have to remember the previous state and then clear things in the previous state, right? But when we do compose, We only have to worry about the current state because we will be rendering the view, and we will probably not render the progress bar at all, which means you don't really have to worry about the old state of your view and just focus on the newer state or the current state. And as a nice side effect to this, there is a huge reduction in boilerplate. That's a very nice side effect to have, because now you don't have to deal with multiple tech stacks and whatever you have currently. And the refactoring tools that you use to write your Java and Kotlin code can still work with this. So Compose is solving a lot of problems really well for us, and I hope that this is going to really change the way how we approach and build UIs. The idea is not novel, because if you are from the web community, you would probably have been exposed to these ideas in React and Vue.js. And even maybe Flutter. But this is a very interesting programming model that helps us ship really faster. These are some of the sources that you can go back to and then look at. Compose is not production ready yet, and that's also one of the reasons why we don't have enough documentation. In order to try Compose, you probably have to go to the Jetpack Compose site and look into the instructions on how to download the source code by yourself. You can download the source code, run a very specific version of Android Studio to work with Compose. You can try exploring. And there are also a couple of links by Leland Richardson, who is also one of the team members working on the Compose project itself. And I would strongly suggest the third article in this thing, Compose from First Principles, because he talks about a lot of different ideas on how this how Compose works under the hood. And there's also a Compose channel on the Kotlin Slack, and the Google team has been incredibly welcoming and responsive to the kind of questions that you ask them. So feel free to ask any kind of questions that you think needs to be answered, or like you don't really understand. They're like a bunch of very helpful people. That's about it. And if you have any questions, I can take them. Yes. Thank you.